Yes, Assalamu alaikum students, how are you? My name is Fasazia and today we are going to start our first chapter, that is on physical quantities and measurement. So today we are discussing about what physical quantities are. Basically, what is a physical quantity? In physics, we have to study a lot of things, like we have heard about forces, we have heard about speed, velocity, displacement, weight, magnetic field, magnetic strength, gravitational field strength, electric field strength, momentum. That things we are going to discuss in our syllabus. So first of all, everything that we study in physics, all these quantities are called physical quantities. Why they are called as physical quantities? Because you can easily measure it. How you can measure it basically? Like for example, if we are going to discuss about length, so how you are going to measure length? You know, in our labs, mostly we have what? Uh, meter rule, or we have what? A meter tape, and sometimes we have also a centimeter rule in our stationary bag. Okay, so by using this, what you can do, you can simply like draw a line of 1 centimeter, 2 centimeter, 5 centimeter, I can say. So what you can do, you can also use your scale, you can also use your rule to measure the length of any line or anything else. Okay, so by using your rule, you can measure the length. For example, if I give you the measuring tape and I told you to measure the dimensions of the room in which you are sitting. So by using your meter rule, you can measure the dimension. For example, you can measure the width of your room, you can measure the height of your room. If you have your table in front of you, so by using a meter rule, you can use by using it, you can find the dimension of, you can measure the dimension of it. So that length is basically called what? A physical quantity. For example, if I'll say, I'll ask like, what is the time right now? So what you can say, you can check your wall clock either, you can check your wristwatch either. Okay, then you can tell me that ma'am, it's now 4 o'clock, or it's like 12 o'clock, it's 12:15. So by using your simple wristwatch or simple wall clock, you can measure the time, how long it passed. Okay, so time is again a physical quantity. Okay, why it is a physical quantity? Because a physical quantity is something that you can measure. Okay, by using any device, you can measure it. For example, if you have fever, so what you can do, like doctor uses thermometer to measure your body fever, like how much temperature you have. So basically that temperature is what? A physical quantity. And for measuring that temperature of your body, what you can use? You can use a thermometer. Okay. So a physical quantity is a quantity by which you can measure. So all those quantities that we discuss in our daily life that can be measured are called physical quantities. Okay. So for physical quantities, what we need basically, what we are going to discuss here, for physical quantities, we basically need, for example, if I'm writing here, like here I have written the definition of that, what? Physical quantity. What is a physical quantity? A physical quantity is a quantity that can be measured and it can be represented by what? A magnitude and a unit. So what is a magnitude? What do you understand by a magnitude? So for example, if I'm saying you that you have 5 kg of apples, okay, so what does it mean? What does 5 means? 5 is basically what? It's a number. It's a number. Okay. And what is kg? Kg is what? It is what? The unit of mass. Okay. So 5 kg is actually what? Basically 5 kg. It itself is what? It is mass. Okay. So that mass is basically what? A physical quantity. Okay. That 5 kg you can measure it by using which device? For example, if you went to a market, so you can measure this 5 kg of apples by using a any kind of balance, for example, electronic balance. So by using electronic balance, you can measure a 5 kg mass of apple. Okay, electronic balance. Okay, so this 5 is basically a number. So 5, a number is basically a magnitude. This is basically the magnitude of your physical quantity, and kg represents the unit of mass. Okay, so by these two things, like a number and the unit, you can represent a physical quantity. Okay, so a physical quantity is represented basically by a number and a unit. For example, if I have written here what 30 degrees Celsius. Okay, so what does it 30 degrees Celsius? Which kind of physical quantity it is? With the help of a unit, you can understand that it is representing what? A temperature. Okay, it is representing what? A physical quantity, that is what? Temperature. And what does 30 means? 30 is basically a number. What it is? It is basically a number. So this number is basically called what? A magnitude. So this number is basically what? The magnitude, and degree Celsius is actually the unit. This one is actually what? The unit. So temperature is what? A physical quantity, and this physical quantity is represented by both a magnitude and a unit. Is it clear? Okay. So a physical quantity, now again move back to the definition. So what is a physical quantity? A physical quantity is a quantity. What kind of quantity? That can be measured, and it is represented by both a magnitude and unit. So what is magnitude? Magnitude is basically just a number. And the unit basically tells you which type of physical quantity it is. For example, if I'm saying 10 meters, so 10 is a number and it is the magnitude of that physical quantity. And meter actually tell me that it's a length of something, okay? The length of something. So that's how I know that the physical quantity is basically length by its unit, and the number represents its magnitude, okay? Now, here I have given you the example that length is equal to what? 10 meters. So 10 is a magnitude and meter is a unit of it. Time, for example, 20 seconds. So 20 is basically what? The magnitude, and S is what? The unit of time. And mass, for example, 40 kilograms. So 40 is a number. So it's a magnitude, and kilogram is a unit. Okay. So by these two things, you can represent a physical quantity. Now, we have now how many types of physical quantities that we are going to discuss here? One is what? A scalar quantity, and the other is what? A vector quantity. So what is basically a scalar quantity, and what is basically a vector quantity that we are going to discuss here? Okay, fine. So now, what is a scalar quantity basically? A scalar physical quantity. A scalar physical quantity is basically those physical quantities that can be described only by magnitude. Magnitude, I told you what? It's just a number. For example, if you have 5 kg of apples, if you have 8 kg of apples, so this 5 or 8 kg represents what? The magnitude. So we have certain physical quantities that just needs the magnitude to describe themselves. Okay, they don't need any kind of direction. For example, you have so many examples for it. We are going to discuss in our syllabus, like distance, speed, time, mass, energy. These type of physical quantities, of course, they can be measured, but they are only described by their magnitude. Okay, no need of any other thing. Like a magnitude and a unit is enough for it. Okay, no need of any other thing. Is it clear? Like for distance, we can say that a car covers a distance of 20 meters. For a speed, that you can say that this cycle is moving with a speed of 10 meters per second. Okay. For example, for mass, you can say that I'm carrying a mass of 1 kg. The energy, for example, the potential energy is 20 joules. Okay, the temperature of water is like it's around 30 degrees Celsius right now. So these are the physical quantities that you can measure by, for example, thermometer, okay, by an electronic balance, by your um, time measuring devices, by speedometer you can measure the speed. But all these are what? Scalar quantities which needs just a magnitude It means a number and the unit to represent it. Okay. But what is a vector quantity? A vector physical quantities are those quantities which needs a magnitude as well as direction. What do you mean by direction? What does direction means? It's mean these physical quantities act at a certain direction. For example, if I move to that example, look at here. A boy pushes a box towards right. What a boy do? He pushes a box towards right with a force of 10 Newton. For example, if I have this box and I'm putting a force of how many? 10 Newton. So this box also moves towards what? Towards right. Starts moving towards right. Okay. So I applied the force towards right and starts moving towards right. So basically, whenever I apply a force, that force is applied in a certain direction. Okay. For example, if you need to pull your laptop towards yourself, so what you are doing, you are applying a force towards yourself, and your laptop is also moving towards yourself. Okay. Similarly, if you are carrying your bag, so what you are doing, you are applying the force, you are pulling it up. Okay. So you are applying the force in the upward direction. Okay, for carrying your bag. Similarly, for example, if you are considering your weight of your body, so how your weight of your body acts, it is acting downwards. Okay, so the force is always acting at a certain direction. So whenever you are describing a force, so it also need a direction. For example, here we have 10 Newton force. So 10 Newton force is basically what? A magnitude and the unit that we have discussed before. And any physical quantity is represented by what? A magnitude and the unit. But for a vector physical quantity, a direction is also necessary. Okay, you need a direction for it also. Okay, so a vector quantity always act at a certain direction. For example, we have discussed before distance also. No? Distance is what? A scalar quantity. For example, I say that the car travels a distance of 20 kilometers. Okay, 20 kilometers. So maybe the car covers that distance of 20 kilometer in any random direction from A to B. For example, this is point A and this is point B. So this car covers a distance in any direction from A to B. Okay. So this is the distance covered by the car of 20 kilometer from A to B. But what about the displacement? If I'll say about displacement, so what you can say, the displacement is basically what? It is the distance covered from A to B in a certain straight direction. Like no curves here. It moves A to B straight in a straight line. Okay. How it moves? It moves in a straight line. Okay. So there is no direction change. Okay. Your car is moving in a straight line from A to B. For example, if you consider about aeroplanes, so the aeroplanes actually cover the displacement. They are not covering the distance, because for aeroplanes you can say that they are covering the displacement in either north direction, east direction, or west direction. So they are taking any specific direction in moving from one point to another point. Okay, but however, when you are saying about the distance, so distance means they are not in a specific direction. Okay, they are moving around, they are covering the length but not in a specific direction. Okay, for example, if you are moving from your home to school, you are going to school, from your home to school, what do your school van do? Like it moves from left, sometimes it moves right, it moves straight sometimes, so it takes turns, it moves towards a roundabout. So what it's covering the distance by changing its direction. Okay, but if the airplanes cover the distance, so it is not called the distance, it is called the displacement, because for the airplanes, the pilot they are instructed like you have to cover the displacement from for example, you have to cover 12 kilometer towards east. Okay, so they are instructed with the direction also. Okay, they are instructed like 20 kilometer towards each, just means 20 kilometers is the magnitude and the unit and with the direction. So vector quantity is always specified with what? A magnitude, unit, and as well as the direction. Is it clear? So displacement is basically a vector quantity. So there are a lot of vector quantities that we will cover in our syllabus. So I'll just give you a few examples here. But in our syllabus, we are going to discuss displacement, force, weight, velocity, acceleration, momentum, electric field strength, gravitational field strength. Later, inshallah, in depth, we'll discuss all these things in detail. Okay? Till then, okay, thank you. Hopefully, you will like this video. If you have any queries about regarding anything, you need more examples, okay, you can just comment me. Okay, like my channel, subscribe it for further learning outcomes. Inshallah, I will cover it. Okay, thank you. Khudafis. Take care.